Hi everyone, this is your math guru. In this video, I'm going to show you how to solve the following analytical geometry question. Please don't forget to click on the like and subscribe button below for more easy to understand math concept. We have two straight lines drawn with equations y equals x minus 2 and 5y plus 3x equals 30. Determine the coordinates of ABC. 2. Calculate the area of the triangle ABC. 3. Calculate the size of alpha and theta. And the last but not the least question, write down the coordinates of D such that ABCD is a parallelogram. Now, if you look at the diagram given, we've been given the equation of the two lines. However, the lines have not been tagged. In order to determine which one has the equation, we're going to use the gradient. Know that if I have a gradient rising from left to right, that is a positive gradient, and if I have a gradient that is dipping from left to right, that's a negative gradient. So therefore, using the standard equation of a graph or of a straight line, y equals mx plus c, I'm going to rewrite my equations in this format so that I'm able to determine if the gradient is positive or negative. For y equals x minus 2, you can see that the gradient here is positive 1, that's the coefficient of x. So what it means is the equation of the line that goes from left to right or rise from left to right will be y equals x minus 2. If you check the second equation, I need to rewrite in standard form. So that will be 5y equals minus 3x plus 30, and then dividing each of the terms by 5, I have y equals minus 3 over 5x plus 30 divided by 5, 6. And if you look at that equation, the gradient, which is the coefficient of x, m equals negative 3 over 5. So that would be for the second equation. I'm going to tag that appropriately, so that's y equals minus 3 over 5x plus 6. Now back to our question. The first part says, determine the coordinates of A, B, and C. Starting with coordinates of A, if you look at point A, both graph or both lines are intersecting at A, and what that means is if I tag the first equation, y1, and I tag the second equation, y2, I'm going to say at point A, the equation of graph 1, or the straight line, will be equal to the equation of the second graph, y2. So always note that where two lines meet, or where any graph meet, the coordinates of the point at that particular point of intersection are the same for the two graphs. So y1, which is x minus 2, is equal to y2, which is negative 3 over 5x plus 6. To make it a linear equation, I'm going to start by multiplying each of the terms by 5. So on my left hand side, I multiply by 5. On my right hand side, I multiply by 5. And then I have 5x minus 10 equals negative 3x plus 30. To solve for x, I have collecting like terms, 5x plus 3x. Then I'm going to move my negative 10 to the right hand side. That will be 30 plus 10, 8x equals 40. And if I divide both sides by 8, I'm going to have x equals 40 divided by 8, that's 5. So at that point, the coefficient of x will be 5. Now I need to find the coefficient of y. All I need to do is to substitute the value of y into any of the equation. I'm going to use the easy one. That's y equals x minus 2. So if I have y equals x minus 2, substitute x equals to 5, that will be y equals 5 minus 2. Therefore, the coordinates y will be 3. So therefore, A is going to be 5 and 3. Moving to B, at point B, note that the straight line is passing through the x-axis. So we have x-intercept, and at that point, at x-intercept, the value of y is 0. So using the equation of that line, I have y equals x minus 2. I'm going to say for point B, at B, y equals x minus 2, and then substituting for the value of y. So at y, or at B, y equals to 0, and using the equation y equals x minus 2, I have 0 equals x minus 2. Therefore, the value of x, if I move my negative 2 to the left-hand side, will give me positive 2. So therefore, point B will have the coordinates x is 2 and y is 0. For the last point, that's at C, also because it's crossing the x-axis, I have the value of y at that point also equal to 0. But note that the line passing through C is my y equals negative 3 over 5x plus 6. So therefore, making y equals to 0, I have 0 equals negative 3 over 5x plus 6. I have 3 over 5x equals to 6, multiplying both sides by 5. Whatever you do on your left, you do on your right. I have 5 and 5, 1. I'm left with 3x equals 30. Therefore, dividing both sides by 3, I have x equals to 10. So therefore, at point C, the coordinate will be x is 10 and y is 0. Moving to the second part of the question, we are to calculate the area of triangle ABC. The first step is to draw a rough sketch of my triangle ABC as shown. I have point B with coordinates 2, 0. I have point C with coordinates 10, 0. And then I have point A with coordinates 5 and 3. Note that the height of A will be the perpendicular height of that triangle, which in this case is my y values, which is 3. So therefore, the area of triangle ABC, the formula for finding the area of a triangle is half times base times my perpendicular height. Therefore, I have my base, that's the distance from B to C, which is 8 units. That is, I have my 10 minus 2 to give me 8. So I have my base equals 10 minus 2, because both lines are lying on the x-axis, so I'm using the coordinates of B and C, that's 8. And then my perpendicular height will be the height of A, which is the y values 3. So therefore, area equals half times base times my perpendicular height, and that will give me 2 in 8, 4 times 3, 12 square units. The third part of the question says, calculate the size of the angles alpha and theta. Starting with alpha, so I have for alpha, to find the angle of inclination, we have tan of alpha is equal to gradient of the line. And if you go back to the equation, we've been told that y equals x minus 2, that's the equation of the line, and the gradient would be the coefficient of x. In this case, m of that line equals to 1. So therefore, if I rewrite that, I have tan of alpha equals gradient, which is 1. Therefore, moving my tan to the right hand side, I have alpha equals the arctan of 1. That would be the second function of your tan button on your calculator. And if you punch that in, we're going to have alpha equals 45 degrees. So I'm going to put that in the diagram. that's 45 degrees. The second part of the question, to find theta, as shown. Not that, to find, so I have 4 theta. Theta is the external angle of the triangle ABC. So if I can find the angle at C here, or this one, the vertically opposite angles, then I'll be able to find theta. Now note that that is the angle of inclination for the line AC. So I start with the gradient. So I have gradient of AC equals negative 3/5. Note that we've been able to calculate that by making y the subject of formula, and the gradient is the coefficient of x. So therefore, to find the angle of inclination of the line AC, I have tan of, I'm going to call that my reference angle, let me call that angle C, equals negative 3/5. And if I find that angle, C will be negative 30.96 degree. Note that that is my reference angle. That is not the angle theta. And because it's negative, that's the acute angle that goes downwards. That's, I'm reading from my x-axis into my fourth quadrant. So that will be 30.96. And vertically opposite angle, what that means is this is also 30.96 degrees. So therefore, to find theta, that will be equal to alpha plus the angle at C, and that's 45 degrees plus 30.96, and the reason being that's external angle of triangle ABC, close bracket. Therefore, the value of theta equals 75.96 degrees. So the angle theta equals 75.96 degrees. For the last part, but not the least question, we have write down the coordinates of D such that ABCD is a parallelogram. Note that because the nomenclature or the naming of the parallelogram is ABCD, so if I follow that, that's ABCN, that means D is going to be somewhere around here in the first quadrant, and then I have D with coordinates XY. To find the coordinates of D, I'm going to use the property of a parallelogram that states that the diagonals bisect each other. So if I can find the midpoint of the diagonal, then I'll be able to find the coordinates of D. So starting with the midpoint of the line AC, I have mid of AC will be equal to, then to use the formula, x1 plus x2 divided by 2, then y1 plus y2 divided by 2. Putting in my values for AC, that's going to be 5 plus 10 divided by 2. Then for my y coordinate, 3 plus 0 divided by 2. And if I solve that or simplify, 5 plus 10, that's 15 divided by 2, that's 7.5. So I have 15 over 2, I'll leave it as a fraction. And then I have 3 over 2 for my y coordinate. So the midpoint of AC, which also serve as the midpoint of BD, will be 15 over 2 and 3 over 2, having that as its coordinate. So therefore, going to the midpoint of the line BD, that's the other diagonal of the parallelogram, I'm going to have that as, using the same formula as given above, I have BD, that's for the x coordinate, 2 plus x divided by 2, and then I have for the y coordinate 0 plus y divided by 2. Note that this value here for the x coordinates, because it's the same midpoint as your AC, must be equal to 15 over 2. So I'm going to solve that by the side to say 2 plus x over 2 equals 15 over 2, multiplying both sides by 2. I have 2 plus x equals 15, so therefore x coordinates will be 15 minus 2, which is 13. And likewise, I'm going to do the same for my y coordinates. So y over 2 will be equal to 3 over 2 because they both share the same midpoint. So therefore, I have y over 2 equals 3 over 2. And if I multiply both sides by 2, I have y equals 3. So therefore, the coordinates of D will be D having x coordinates of 13 and then y coordinates of 3. Thanks for watching. Bye.